So in this question, we're told that the graph shows the volume of liquid, L litres, in a container at t seconds. And we can have a look at the graph and we can see that on the y-axis we do have volume in litres, and on the x-axis we've got the time in t seconds. So we're asked to look at this graph and then find its gradient. So to find the gradient of the graph, we're going to look at the change in y value, so the change in volume, divided by the change in the x value, so the change in time. So if we write that out, so m, which is often used to describe the gradient, is equal to delta y, delta being change in, over delta x. So then a good way to do this is to draw out a big triangle on the graph so that we can work out easily, we can see easily the change in y and the change in x. So if I'm going to start at this point here, come down to here, and then we can do the same along the x-axis. This is going to be the change in y, and this is going to be the change in x, these distances. So the change in y is going to be equal to the y value at the top here minus the y value at the bottom here. So if we go along the line, the y value at the top is 16 and then at the bottom it's 4. So the change in y is 16 minus 4, which is equal to 12. And then similarly for the change in x value, x at this furthest point is 8, and then x at this point here is going to be 0. So we have 8 minus 0 is equal to 8. So m is equal to change in y over change in x. So we have 12 divided by 8, and that gives us an answer of 1.5. And you'll get the first mark here for using a process to find the gradient of the line, so using a method to find the gradient. And then the second mark is going to be an answer mark for the correct final answer of 1.5. So now for this part of the question, we're asked to explain what this gradient represents. Now I'm going to refer back to what we did in part A here. So instead of using numbers to calculate the gradient, we're looking for a more qualitative response. So we're using words and the context of the question to explain what the gradient represents in this part of the question. But again, I can use a similar approach to that in part A. So the gradient is equal to the change in y divided by the change in x, and we use that in part A. However, this time, instead of using numbers, I can just look at the words and the context. So the change in y is the change in volume of liquid in the container. Or if we want to look a little bit more closely, it's the change in the number of litres. And that's going to be divided by the change in x, so divided by the change in time or the change in the number of seconds. Now one way, quite an efficient way of writing this out, is going to be by taking the change in the number of litres, so the change in y, and we're dividing that by the number of seconds that passes, or I could write this as per second, because that's still going to represent the gradient. So for every second that passes, how do the number of litres in the tank change? And that gets us an expression for the gradient in terms of words with the context of the question. So alternatively here, because we have a value per second, we could use the word rate and say the rate at which the container fills. Or we'd still get the mark for saying something like the number of litres added per second, as long as there's an explanation relating to the rate of change of volume with time. Now for the final part of the question, we're told that the graph intersects the volume axis at L equals 4, and again we're asked to explain what this intercept represents. So if I just have a look at the graph, we can see here that it intersects the volume axis, so the y-axis, at L equals 4, and that is going to be the volume when the time is equal to 0. So when x is equal to 0, y equals 4. So when the time is equal to 0, the volume is 4 litres. And that's really all we need to know and write down to get the mark here. So you need an explanation relating to the volume of liquid in the container at the start of this kind of experiment that's going on here. So to get the mark here, I'd simply write the number of litres in the container. So we're referring back to the context of the question. We know that it's in a container when t equals 0. Or alternatively, you could say the amount of liquid in the container to start with, or the initial amount of liquid in the container. Any of these ways of phrasing it will get you the mark for this question.